this example, I want to show you guys how you can solve this problem using the z-table. So a soft drink machine is regulated so that it dispenses an average of 200 milliliters per cup. And the amount of drink dispensed is normally distributed, so we have a normal distribution with a standard deviation equal to 15 milliliters. So if we draw the distribution, we know it's bell-shaped with a center at 200, and we want to draw in our 3 standard deviations up from the mean and the 3 standard deviations down from the mean. An approximate drawing, and then we can easily answer these problems. It says what proportion of cups will be filled less than 180 milliliters. So the first step is to shade in the proportion that we're curious about. This is what we want, and so we can kind of get an idea of what the answer should be. And then in notation we can write out the problem. So what is the probability that X will be less than 180 milliliters? This is going to be equal to, if we standardize it, the probability of z less than 180 minus the mean, this is the z-score, divided by the standard deviation, which is equal to the probability that z is less than negative 1.33. Now to find this value, we have to go to the z-table or the standard normal table. So let's go over to the standard normal table. And we need to find the beginning of our z-score. So we need to find a negative value. And this should be negative 1.3. And then we need to find the hundredths place of 0.03. So that's this fourth column over. That's 0.03. You guys can see that okay. And we see that the area that falls below the z-score of negative 0.33 is 0.09176. So that's the answer to this problem. So this is 0.09176. 0.09176 is then this proportion. That seems to make pretty good sense according to our drawing. Now for the next problem, we want to find something a little bit different. We want to find the area that falls above a particular value. So let's go ahead and draw that in. We want to find the area that falls above 225. So we want to shade in the region. And to find this, we will then write it in notation as the probability of X greater than 225 milliliters. This is equivalent to the probability that in the standard normal distribution, z is greater than 225 minus the mean, all divided by the standard deviation of 15, which is equivalent to the probability that z is greater than 1.67. Well, something that we have to remember is when we look at the standard normal table, it will always just give us this area below the z-score of 1.67. We want the area above, so we can easily find this by just taking whatever we get in the table and subtracting it by 1. So let's go over to the z-table and find the area that falls below 1.67. And we want to find the beginning of our z-score, so the first and second digit is 1.6, and we can find that right here, 1.6, and scroll over to the column of 0.07, and we get then a value that falls below 1.67, or the area is 0.95254. So 0.95254, come back over here, this is equal to 1 minus 0.95254. So just to make sure that you understand what that area is, this is this area, the stuff that we don't want, but that falls below 225 in our distribution. We want to find the area above, so if we subtract this from 1, then we'll get this area, which in this case is 0.04746. So that's this area. So we'll write in our answer here, 0.04746, and that seems to make sense according to what we've drawn on our distribution. So for our very last problem, we want to find the area of number of cups, or the likelihood that the fill is between two numbers. So for that one, we want to find what the proportion of cups will be filled between 180 and 225. So we want to shade in this region. And to find that, we will first write it in notation. So the probability that X is between 225 and 180 milliliters is then equal to the probability that our Z is in between 180 minus 200 all over the standard deviation of 15 and is less than 225 minus 200 over 15. And so this means that our Z will be between negative 1.33 and positive 1.67. So we can calculate our Z-scores. If we recall, if we want to find the area between two Z-scores, then we have to find the probability of everything following below our upper bound, so probability of Z less than 1.67, and then we'll subtract off the lower bound, so the probability of Z being less than negative 1.33. This will then give us the area in between. So this is then equal to, we already know this area because we found it before, as 0.95254. So we found that in the previous problem. We can also look that back up on the Z table, but we don't have to. We're going to then subtract off the area that falls below negative 1.33 in the standard normal distribution. Again, we've already found that as 0.09176 in part A. Subtract these two values, we'll get the area that falls between. We get 0.86078. So there's 0.86078 will be the proportion of cups filled between 180 and 225. And that answer really does seem to match up with what we have drawn on our distribution.